to be doing the qualitative analysis for the Neco 2022 examination. We are going to be analyzing zinc carbonate that is labeled X and aluminum chloride that is labeled Y. For this analysis, we will require silver triisonitrate 5, dilute HCl, aqueous ammonia, sodium hydroxide, and triisonitrate 5 acid. We're also going to require litmus papers, droppers, and sets of test tube, and then lime water. Now, in this analysis, there are a few things that you should know. You should know that aluminum chloride is also referred to as a Lewis acid, and zinc carbonate is insoluble in water, while the Lewis acid, aluminum chloride, is soluble in water. Let us begin our analysis.
Okay, we have a question here that says X and Y are inorganic salts. Carry out the following exercises on them, record your observations, and identify any gases evolved. State the conclusions you draw from the result of each test. A. Put all of X in a test tube and add about 10 cm³ of distilled water. Shake thoroughly and test the resulting solution with litmus paper. Divide the solution into 3 portions. To the first portion, add sodium hydroxide, that is aqueous sodium hydroxide in drops, then in excess. To the second portion, add aqueous ammonia in drops, then in excess. And to the third portion, add dilute HCl. B. Put all of Y in a test tube and add about 10 cm³ of distilled water. Shake thoroughly and test the resulting solution with litmus paper. Divide the solution into 4 portions. To the first portion, add aqueous sodium hydroxide in drops, then in excess. To the second portion, add aqueous ammonia in drops, then in excess. To the third portion, add excess dilute HCl, and to the fourth portion, add triisonitrate 5 acid, followed by aqueous silver triisonitrate 5, and then aqueous ammonia. From your results, identify the cations and anions in samples X and Y. So at the end of our analysis, this is how our table looks like. We have test, observation, and inference. Say X in the solid state plus 10 cm³ of distilled water plus shake plus litmus paper. When we dissolve the X in distilled water, we have that our observation was that X partially dissolves in distilled water, and our inference is that X is insoluble. Then, with testing the resulting solution with litmus paper, we noticed that there was no effect on blue and red litmus paper, and our inference is that X is a neutral salt. Then to the first portion of solution X, we added aqueous sodium hydroxide in drops and then in excess. When we added in drops, we noticed that a white gelatinous precipitate is formed, and our inference is that zinc 2 ion, lead 2 ion, or aluminum 3 ion present. And when we added in excess, the precipitate is soluble in excess to give a colorless solution. And our inference is that zinc 2 ion, aluminum 3 ion, or lead 2 ion present. Then to the second portion of X, we added aqueous ammonia in drops and then in excess. Our observation when we added in drops was that a white gelatinous precipitate was formed. That means that for our inference, we have that zinc 2 ion, aluminum 3 ion or lead 2 ion present. And then when we added in excess, the precipitate dissolved. That means the precipitate is soluble in excess aqueous ammonia. It dissolves to give a colorless solution. And from there, we said our inference is that zinc 2 ion confirmed. Then to the third portion of solution X, we added dilute HCl. Upon addition of dilute HCl, there was effervescence, a brisk effervescence occurs, and a colorless, odorless gas was evolved, which turns dark blue litmus paper red and turns lime water milky. And from there, we have our inference that the gas is acidic, and have the CO2 gas from CO3 minus or HCO3 minus present. Then we begin the analysis of Y. Then we dissolved Y in 10 cm cube of distilled water and then tested with litmus paper. When we dissolve Y in litmus paper, we discover that Y dissolves to give a colorless solution, and our inference is that Y is soluble in water. And upon testing the solution with litmus paper, we notice that Y turns blue litmus paper red, but there was no effect on red litmus paper. And our inference, our conclusion is that Y is acidic, or Y is an acidic salt. Then to the first portion of Y, remember we divided Y into 4 portions. To the first portion of solution Y, we added triazonitrate 5 acid, followed by silver triazonitrate 5, and then aqueous ammonia. Upon addition of the triazonitrate 5 acid, we notice that triazocarbonate 4 upon addition of the triazonitrate 5 acid, we notice that CO3 minus, SO3 minus, S2 minus was not present. So our inference is CO3 minus, SO3 minus, S2 minus absent or not present. Then when we followed it up by the addition of silver triazonitrate 5, we observe that a white precipitate is formed, and our inference is that chloride ion present, that is Cl minus present. Then when we added aqueous ammonia after the addition of the silver triazonitrate 5, we notice that the precipitate dissolves in excess. The precipitate dissolves in aqueous ammonia to give a colorless solution, and our inference is that chloride ion confirmed, that is Cl minus confirmed. Then to the second portion of solution Y, we added sodium hydroxide in drops and then in excess, and we notice that a white gelatinous precipitate is formed, and our inference is that zinc 2 ion, aluminum 3 ion, or lead 2 ion present. Then upon addition in excess, our observation was that the precipitate dissolves in excess to give a colorless solution, and our inference is that zinc 2 ion, aluminum 3 ion, or lead 2 ion present. Then to the third portion of solution Y, we added aqueous ammonia in drops and then in excess. On addition in drops, we observe that a white gelatinous precipitate is formed, and our inference is that zinc 2 ion, aluminum 3 ion, or lead 2 ion is present. And then when we added the aqueous ammonia in excess, we notice that we observe that the precipitate remains insoluble in excess, and our inference is that aluminum 3 ion or lead 2 ion present. Some people can report only aluminum 3 ion present here because lead does not form a white gelatinous precipitate, rather it forms a white powdery precipitate. Then to the fourth portion of solution Y, we added dilute HCl, and our observation was that no precipitate was formed, or we say no visible reaction. And here we said our inference here is that aluminum 3 ion is confirmed. And then according to our question, we are asked to identify the anions and cations in X and Y. For X, find out that X contains zinc 2 ion and triisocarbonate 4 ion. Therefore, X is likely zinc triisocarbonate 4, and that Y contains aluminum 3 ion and chloride ion. Therefore, Y is likely aluminum chloride.
Since X is insoluble, they might not ask you to dissolve in distilled water. Rather, they might ask you to add dilute HCl to X. And for that, I have also drawn up a table that will guide you on the analysis for that.
So this is the table. When you add dilute hydrochloric acid to X, you notice the brisk effervescence. Then we divided into first and second portion and analyze for cations with sodium hydroxide and aqueous ammonia. The results, the inferences are written there and the observations. Then you might also be asked to heat X. And when you heat X, you notice that a colorless, odorless gas is evolved that turns down blue litmus paper red and turns lime water milky. And then you notice that the residue is yellow when hot and turns white on cooling. And then your inference will be that the gas is acidic and that carbon dioxide gas is evolved and CO32 minus is present, and that residue is zinc oxide. Then they might ask you to add dilute HCl to the residue, and you observe that the residue dissolves without effervescence to give a colorless solution, and then your inference will be that the residue is a base. Then the analysis of Y is the same like we did earlier. To avoid cramming, we have been able to put down for you the chemistry of the reactions that takes place. All the reactions have been carefully written down. All the reactions, when you add in drops, in SS, in addition of HCl, addition of silver nitrate, everything has been written down here in a stepwise manner so that you don't need to cram, rather understand the chemistry of the reaction that is taking place. Understand the chemistry. This is for the analysis. The previous one is for the analysis of zinc carbonate, and this particular one is for the analysis of aluminum chloride. Remember, aluminum chloride contains aluminum 3 ion and chloride ion. So here we tested for the chloride ion, and we also did the test for the cation, which is also did the test for the cation, which is aluminum 3. So all the steps are there for you, so that I don't need to cram. Rather you should read to understand, study these things, and you find out that the reactions are very, very interesting. Thank you for watching, and don't forget to subscribe to my channel. God bless you.